Hi class. In this video here, I want to walk you through problem number 10. Specifically, the last part of the problem can actually be pretty tricky, so pay attention to the whole length of this video. Okay, so the following data represent the weight in grams of a random sample of 50 candles. So I have 50 candles here, okay, and for whatever reason, we collected the weights, how much these candles weigh. All right, so the first question says determine the sample standard deviation weight. Okay, so you don't want to do this by hand, obviously. You want StatCrunch to do this for you. So I'm going to open up the data in StatCrunch. And now that I've got the data right here, it's very simple. I'm going to go stat, summary stats, okay? And I want the data's in a column, so columns. I'm going to hit var1, and then all I'm going to do is hit compute. And you should see right here, standard deviation, perfect right here. It's 0.068. So this wants us to round to 2 decimal places. So I'm just going to take 0.06. The 6 is going to round to a 7. So 0.07. And we got it. Perfect. Next question, on the basis of the histogram on the right, so this is what the data looks like. Let's comment on the appropriateness of using the empirical rule to make any general statements about it. So if you look at this, it's a little hard to understand exactly what we see here, but you notice this slight bell shape to it. It's not perfect, but it does kind of look like a bell curve. So the empirical rule here can be used. All right, so that's great, perfect. Next, use the empirical rule to determine the percentage of candle with weights between 0.7 and 0.98 grams. Okay, so it's telling you, this is where it gets a little tricky. It's telling you that the mean of all these candles is 0.84. Okay, so if you look back here, the standard deviation was 0.07. So if you take the mean you have here to go down to 0.7, you had to go 0.14, all right, or 0.14 grams. To go from 0.84 down to 0.7 is 0.14 grams, or 2 standard deviations. All right, because if you take 2 times 0.07, you get 0.14. So it's 2 standard deviations down to here, and it's the same thing to go to 0.98. So it's 2 standard deviations from the mean below to 2 standard deviations to the mean above, 2 standard deviations above the mean. So what our empirical rule tells us is, if you take the mean minus 2 standard deviations to the mean plus 2 standard deviations, 95% of data will be between those two values. So let's see if that is true. Perfect, we got it. So the trick was here to see that this was 2 standard deviations below the mean to 2 standard deviations above the mean. Okay, the next question says, determine the actual percentage of candles that weigh between 0.7 and 0.98 inclusive. So this is a little tricky. What you have to do is you have to calculate the number of weights that are actually between these two. So there's 50 total. So it's actually easier to maybe just look at this and see if there are any outside that range. So just looking through, you see any that are outside of 0.7 and 0.98, you have to be very careful. There is one. There's 0.99. So what that means is 49 of the 50 are inside that range, which is 0.98 or 98%. We got it. Now the last one here, use the empirical rule to determine the percentage of candles with weights more than 0.91 grams. All right, so this is a little tricky. How the heck will we do that? Well, remember the mean was 0.84. So if you take 0.84 and add 1 standard deviation, you get 0.91, right? So you need to figure out how many or what percentage will have more weight than 0.91 grams or more than 1 standard deviation from the mean. Well, if you look at our empirical rule here, okay, from the mean to 1 standard deviation is this like orange area here. So this yellow, these two yellow areas here are percentages, okay, represent more than 1 standard deviation from the mean. Well, to help you out here, when you're more than 1 standard deviation from the mean, so greater than 1 standard deviation above, this plus this percentage is here will be 16%. So let's check that. Great, we got it. All right, class, I hope this helped.